Hi, I'm Maria Janet, your mentor for today.
Good day. I am Maria Janet Gonzalez, and today we're going to talk about, well, ordering principle. But first, let's have the meaning of that. So, ordering principle states that every non-empty set of the positive integers has a least element. Okay. Let me just highlight random words. Non-empty set of the positive integers has a least element. To prove that, let P of n are equal to every non-empty subset of the positive integers that has a least element. Whereas n is equal to the number of elements in the set. Now, let n equals 1, then P of 1 will be a set having only one positive integers. Again, only one positive integers. So with that in mind, the set will be P of 1 equals R of 1. Because we are not just looking for only one integer, okay? One integer. With that in mind, P of n is true for n equals 1. Okay, now let's move on. What about t? So in here, the case here is we have n equals 2, then the p will be p of 2. And with that in mind, we know that a set is having two positive integers. So it will become p of 2 equals r of 1 and r of 2, or the set of r of 1 and r of 2. Okay. With that in mind, p of n is true for n equals 2. Okay. And this is the last one. What about, let's assume that p of n is true for n of n equals k, where k is a positive integers. Let the set be p of k, set of r1, r2, up to rk, okay? Then, with that, we can say that the set of pk has elements in it and assume that the least element in the set exists. So there is the smallest element, and let it rj. Okay. And the next thing is to prove that P of n is true for nk plus 1. In what way? Let's have that. Where k plus 1 is a positive integers. Do not forget that it is always positive integers. In this, to prove this ordering principles, okay? Then pk plus 1 is equal to r of 1, r of 2, r of j. You only add rk plus 1, okay? And it is either r of k or the u element will be the least element. So either of them now. Now, let's proceed. Okay, just like what I've said a while back, ordering principles states that every non-empty subset of non-negative integers contains the smallest element. I just changed the least for smallest. Okay, now let's move on. Let's have it as an example for you to understand that. Okay, so the set S is equal. The set S here is equals to 2k plus 1, such that k is an element of positive integers. Positive integers. Okay, so let's have that first. Since that is the problem, so we will have it as 2. The first thing is 2, and you will put k as 0 because here, in this case, we have the given as this, as this, as this. K is greater than or equal to 0, so we will start with 0. start with 0. Okay. Now we start with 0. I got a little problem there. So 0, 0 plus 1. Okay, what about the second number is? Okay, we will have it as 2, 2, 1 plus 1 now. Okay, what about the other things? We will now use 2. 2, 2 plus 1. Okay, I think enough for this. Okay, 2 plus 1. And so, for the last example is we're gonna use 3 also because see, just like what I've said a while back, it says here that where k is greater than or equal to 0. So 2, 3 plus 1. Okay, now there you go. There you have it now. Okay. Let me just rewrite it. 2, 3 plus 1. And so on. And so forth. Okay, and with that in mind, you will now have 2 times 0 plus 1 is equal to 1. The next thing is 2 times 1 plus 1 is equal to 3. And the next number is 2 times 2 plus 1 is equals to 5. And the last thing is 2 times 3 plus 1 is 2 times 3 plus 1 is equal to 10. And so on and so forth. So with that in mind, we can say that S, okay, therefore, we can say that S is the set of positive odd numbers. Alright, so there you have it. 1, 3, 5, 7 are examples of odd numbers. With that in mind, we can say that S is the set of positive odd numbers. And of course, the smallest number is, and the smallest number that we have here is what? Yeah, that's too easy. It is the smallest number in the set. Smallest number is 1. Okay? 1. There you have it. Okay? That's the end of our lesson for today. I hope you understand what will ordering principle is. Okay, goodbye.